Hello everyone and welcome to this beginner's tutorial on Python basics. This tutorial is good for programming beginners, but also if you're coming from a different language and you want to start coding Python as soon as possible. In this video, I will present you the basics of coding in Python in general. We will start with the variables, the keywords, operators, and built-in functions, which are one of the powerful features of Python and which will make our coding life much easier, providing some shortcuts to common instructions, like converting numbers into binaries or strings, or returning length of an object, for example. These functions are very handy because you don't have to write their code on your own, since they are already included in Python. Then we will talk about applying conditions and looping iterations using the while and for loops, and we will check how to create functions and Lambda functions. We also talk about local and global variables together with the functions, and then we will talk about the containers, the 4 types of containers in Python: lists, tuples, sets, and dictionaries. So you can see the content is really very basic. It's really for beginners in Python, but it will show you most of coding essentials in just around 60 minutes. So stick around and don't forget to enjoy your coding. So how can you practice? How can you run your code? For practicing, you can run your code using an online Python shell or interpreter. So you don't have to install anything on your laptop. However, you won't be able to read or load data files on your hard drive. So maybe saving your work also for later sessions, you won't be able to do that. So it comes with its problems. And in this video, I'll be using the Jupyter notebook to show you examples. So if you are new and you choose to install Python, which is highly recommended, you can install the Anaconda platform. It comes with Python and many other interfaces like Jupyter Lab, Jupyter Notebook, and Spider. So if you want more details on this, on the installation of Anaconda, you can visit my other video on this topic. The advantages of using Python is that you don't have to compile your code. You simply type your instructions and you can execute instantly, at least from the user's point of view. And so many things are automated in Python. For example, variables are created automatically. And here we start our first topic. And what exactly are variables? Variables are a memory location that is reserved to store a value. For example, as soon as you type a equal 2, Python will reserve a memory location where the value of a, which is 2, for now will be stored. So in Python, numerical variables can be of different types depending on the value they contain. For example, if a is equal to 2, then it's an integer. If a is equal to 2.4, then it's a float. And if it's equal to, for example, a certain sentence or a word, it's a string of characters. And this is a different type also. It's non-numerical type. And of course, all of these types, they don't come in the same size. They have different size requirements. So the size of memory needed to store each value will be different. A float, for example, will be larger in size than an integer, since it carries more details about the numerical value. In other words, the precision in a float is higher than in a case of an integer. And when you type a equal 2, for example, Python will store the value in the smallest possible type. It is a common practice in programming to save memory. Now, of course, if this variable will be changed during the program, a different value later on is attributed to the variable. So Python will change and modify its type automatically. Now, if you are familiar with the complex numbers, these are also supported in Python. To declare a complex number, you can use the following syntax. My complex number is equal to x, the real part, plus y, the imaginary part, where we added the j letter to tell Python that y here is an imaginary number. So in the example where a is equal to plus 3j, means that 2 is the real number and 3 is the imaginary number. So we have seen these types: integer, float, and string. One more type is also commonly used, which is the Boolean variable. These variables can have one of two values, either true or false. And some variable names can't be used in Python because these are keywords that are already used by the program. I will not go through all of them right now. However, it's good to be aware that you can't use those as variable names in your program. So let's jump into our Python interface and try what we have just learned. So this is my Jupyter Notebook page, and this is how it looks like. I will not go through all the details here because it's just an interface. I will be zooming in. I'll do a zoom in here so you can see better. So first, let's consider a variable a equal to 2 and b equal to 2.3. If I run the cell using shift return in this case, these variables will be stored in the memory. However, I'm not seeing any display, anything on my screen, unless if I type print a and b. So I have to specifically put the command to print things on the screen. So I'm printing a and b, and when I run these, I have 2 and 2.3, which are the values of a and b. And if you want to know the type of a variable, you can use the built-in function type a, which will provide me the type of the variable a. In this case, it's an integer because a is holding the 2 value. Now, if I consider a different example, for example, s equal to coding is fun, and I'm printing s, I can see the content of the variable s, and then the type of s is equal to str, which means string. Now, if I change the value of s during the same program, which is the same variable, s now is equal to 2, Python will automatically change the type of the variable s. And to make sure that it's done this way, I will type the function type s, and then you can see that s is now an integer. It used to be a string, now it's an integer. Now let's consider a variable b that is equal to true with capital T. So you can see that the keyword true here is colored in green, which is automatically done by the interface of Python, Jupyter Notebook here, which means I wrote it correctly. If I write small t, it doesn't work. So it has to be capital T. And I will try to check the type of this variable, and as we can see, it's a Boolean. What does this mean is that Python automatically guessed the real type of my variable. It will always choose the smallest in size in order to save memory. And another example can be the complex numbers here. I'll declare my first complex number, 2 plus 3j, the real part, which is equal to 2, and the imaginary part, which is equal to 3, and a second complex number, my complex number 2, which is equal to 3 plus 4j. And then I'm going to try to add these two. I will sum up those two complex numbers and put the result in my complex number variable. And I will print the result. As you can see here, it's 5 plus 7j, which means that Python added the real parts together and the imaginary parts together. If I try to check the type of my result, Python will tell me that it's a complex number, as we can see on the screen. Now, as we have said previously, there are some variable names that are forbidden. For example, if I try to call my variable end equal to 2, I'll get an error message stating that it's an invalid syntax. So anyway, when I typed end, it was colored in green. So this is the first hint that this is a built-in keyword from Python. So you don't really have to memorize all of them, although it would be good. But if you see something colored in green, you should know that it's not really something that you can use as a variable. Of course, the colors and the hints will depend on the interface, but here I'm talking specifically about the Jupyter Notebook interface. Okay, so now we are ready to talk about comparison operators. Basically, we have 6 different comparison operators. As you can see here, we have the strictly lower than, strictly superior to, less than or equal to, greater than or equal to. Equal to, just be careful here, you have to use 2 equal symbols, otherwise you wouldn't be using the comparison operator. And then we have the different from operator. This is how you write it. Then you can combine any conditions using these operators, using the keywords here, and, or, not, or is not. Let's go and see those in example. So let's consider, for example, a variable a equal to 3, then a variable b equal to 4, and then I will print the result of the condition a is strictly higher than b, which is false in reality. And this is what I will get here. As you can notice, I've printed false, and this is the result of the comparison. Then I can take another example where I'm combining two different conditions here. A is lower than b, and a is strictly positive. And this is true because it's real, actually. A is less than b, 3 is less than 4, and a is positive. And this is how you get the true result here. Another example is a different than b. Print a is different than b, and it's true in this case because we have a equal to 3 and b equal to 4. One more condition here as an example. I'm gonna print a is lower than b, or b is positive. So at least one of these conditions should be true because I've used the or keyword here. So one of these two conditions should be true in order to return a true value, and this is what's happening here. We have a true as a result. Now we can move to the if statement. First we have to use the keyword if to state a condition. Is here the condition 1, and if this condition is true, the block of instructions inside here is executed. If not, in this case, we will move to the second condition because we have the keyword elif, which means else if condition 2. And if this condition 2 is true, then in this case, we have another block of instructions that we can execute. If both of these conditions, condition 1 and condition 2, are false, in this case, the program will go to the third keyword, which is else here. And we have another block of instructions that will be executed. Notice that all the instructions are indented. They start with a certain space at the beginning of a line, and this is to tell Python that this block of instructions are inside of the if statement. You go back to the beginning of the line, you're no longer inside of the block of instructions of the if statement. In other coding languages, if you know C or C++ or anything else, we used to use delimiters. For example, in C++, we use braces. In Python, we don't use any characters to delimit the blocks, the beginning of a block or the end of a block. In here, we use indentation. So in this case, if you erase this tab space at the beginning of the line here, you are no longer inside of the else statement. You are outside, up one level. So also for the if condition statement, you don't have to use the whole structure as we are seeing here in this complete structure, complete example. You can use simply the if condition. You have a block of instructions, otherwise nothing, and the program will simply continue normally. And you can use also elif if you have only two conditions, condition 1 and condition 2. Or the if condition is true, then you have a block of instructions, and then you have the else if the condition is false. You have a different block of instructions in this case. So you don't have to stick with this complete form. You can choose any other form depending on what you need to do in your program. Okay, let's see an example about this. Here I will consider three variables, a equal to 3 and b equal 5, c equal 10. And I will try to guess which is the greatest or the highest number, the highest value among these three variables. So first of all, I will be using two conditions. If a is strictly lower than b and keyword b is strictly lower than c, in this case, I will be printing c is the greatest. And elif, meaning if it's not true, I will be going to condition number 2. So b is higher than a and b is higher than c. In this case, b is the greatest. And else, if all these conditions, the two previous conditions will fail, then I have no other choice but to put a is the greatest. So this is a simple example just to show you how it works. You can, if you are willing to, you can put two if conditions, one inside the other. I'm going to show you how it works here. So I could put here another if inside. For example, I don't know, if let's say C is positive, whatever. And here in this case, I will be printing C is positive. Okay, now the reason I did this is to show you the double indentation in this case. Here you have two tab spaces just to tell Python that this print here is inside this if statement, which in return is inside the bigger if statement. So you see you have double indentation here, single indentation at this level. And of course, if we can run this, we will get C is the greatest in our case because 10 is higher than 5 and 3. Now I'm going to run this again, and you have C is the greatest and C is positive because in this case C is positive indeed. Now let's talk about looping. Looping is used for repeating a block of instructions taking into account the condition. For example, here if we are using the while condition, don't forget these 2 points. These are a syntax of Python. So while condition is true, I will be executing these instructions in here. So as long as this condition is returning a true value, I will be repeating this block of instructions over and over again. Let's look at this example. So I will consider a variable a equal to 0, and while a is less than 10, I will print a, and then I will increment its value by 1, meaning the new value of a is equal to the old value of a plus 1. And this one is basically a small loop that will be counting and printing from 0 up to 9. 10 is excluded because a should be strictly lower than 10. Let's check this example in our Jupyter notebook here. So a is equal to 0, while a is less than 10, 2 point, print a equal a plus 1. And if I run this, I will be getting values between 0 and 9. And as we said, 10 is excluded. If I put a is less or equal to 10 here, I will run it and I will get the 10 that is included in my counting here. Okay, now I will move to the for statement, still in looping. So the for statement loops over a sequence of elements and executes the block of instructions within the loop. So how does this happen? Let's take this as an example. Let's take s equal coding is fun. It's a string, meaning a table of characters. So basically for I, a variable in this sequence in S, would mean that for I taking the value first of C, then the value of O, then I will be equal to D all over the table until I is equal to N, which is the last character in this sequence. Then inside, remember, the space here are also considered as characters, and I will be equal to space when it reaches this space. So anyway, I will be printing I inside of the for sequence, and then I don't have to increment the I equal I plus 1 like in the while loop, because here it's the for loop that will be doing this job. It will be changing the values of I following the whole sequence here. So I don't have to increment any values here in this case. We can also use the for statement to loop on numerical values. Let's consider, for example, the variable s here. It's equal to range. This is a built-in function from Python, and range is a function that takes 2 or 3 values. Let's say here we will provide 2 values for the range function, 0 and 10, and in this case the function will return numbers, consecutive numbers between 0 and 10. However, 0 is included in the numbers and 10 is excluded. So for I in S, in other words, for I equal to 0 and for I equal to 1, then 2, then 3, up to 9, I have a block of instructions that I would like to execute. Let's take a look at this example. So first of all, I will throw the result of the range function. I will be using it between 0 and 10. I will throw it into a list function. We will discuss this later on in this chapter, in this video. However, for now, let's look at the results provided by the range function on its own here. So it's numbers between 0 and 9 included. So this is what I provided. If I put 20 here, I'll be having numbers between 0 and 19 included. What does this mean? It means that this function is providing me a series of numbers, consecutive numbers, and I can provide the step as a third character. For example, if I put 2 here, I will run the range function and I'm gonna get 0, 2, 4, 6, and so on. I can put 3 and it's going to be adding 3, starting from 0 plus 3 equal to 3 plus 3 equal to 6, 9, 12, 15, and 18. So I will be using this range function to demonstrate how to use the for loop. S equal range 0 to 10. For I in S, print I. So basically, I will be simply printing the numbers provided by the range function. And it's going to print those here. Now, you may have noticed that we have a column here instead of a line in this case. It's because the print function, every time it prints a value, it will be returning to the line automatically. We can avoid this by adding comma and equal to space. So the last character will not be a return to the line character, but it would be a simple space. And in this case, if I run, I will have simply a space between a number and another, as you can see here. Okay, at this stage, we have to introduce two keywords, the break and continue keyword. So what break basically does is that it breaks outside of the loop. Whenever the program will encounter this keyword here, break, it will go out of the loop. It will not continue to repeat the block of instructions anymore. And usually breaks are put inside of a loop, but under a certain condition. For example, here I have I equal 1, while I is less than 10. I will execute this. I will print I, then I will increment I by 1. And if I is equal to 5, then I'm going to break the loop. It means that I will only stop when I is equal to 5, and I will not continue until 10. I could have simply skipped this part and put I is less than 5, and it would have done the same job. Just to show you an example and tell you how it works. So whenever you need to break a loop under a certain condition, you can use the break keyword. Here also for the for loop, you have for I in range 1 to 10. If I equal to 3, then we will break. Otherwise, we will simply print I. And what this basically does, it will print 1 and 2. And since I is equal to 3 will lead us to the break, we will break outside of the for loop without going through the print I. So we will not be printing I equal 3. We will not be printing 3 in this case. Okay, let's see an example here. I have I equal 1, and then while I is less than 10, I will print I. And then I will increment I by 1, I equal I plus 1. And if I will reach the 5 value, if I equal to 5, I will put the break keyword here to throw me out of the while loop. So first of all, notice the double indentation in this case, because you have two levels here. One level to be inside the while block of instructions, and then you have another level which is inside the if condition, the if statement, which is inside the while in its own. So you get the idea. You have double indentation here. These guys, they have a single indentation space. And what this program does is that it will print 1, then 2, then 3, then 4. And since I'm incrementing here for I equal 4, Okay, I'm printing I equal 4, but then I will be equal to 5. And if I is equal to 5, it will throw me to the break keyword, will lead me to the break keyword, which will throw me out of the while loop. So this program basically counts from 1 to 4, because when I will be equal to 5, I would already be stopping the loop. And this is what it does here. This is an example. We've run this. So 1, 2, 3, and 4. The same keyword break can also be used inside the for statement loop. For I in range from 1 to 10, if I is equal to 3, then I will break, and it works the same way as we just saw. I will print I, this is outside the if, just mark that this is a single indent space. And what this program will do is that it will print I equal 1, then I equal 2, and when I is equal to 3, it will simply go to the break keyword. It will stop the loop before reaching the print I. So it will be printing only 1 and 2 in this case. Now another keyword is the continue. It's also interesting to see here, because the continue will only break the current iteration. It will not break outside of the loop, but it will stop the current iteration. How it happens here, for example, if I take for I in range 1 to 10, if I equal to 3, then continue instead of break. Meaning this word here, this keyword, will put me back at the beginning of my loop. It will increment I by 1 value, because here we have a different range. It will go to the next value of I, and we will not reach the print I, but the looping will continue in this case. We will not break the whole loop, but rather the single iteration where this condition is true. And in this example, for I in range 1 to 10, so I is equal to 1, so this one is not true for the moment, so I will print 1, and this is what we have here. Then I will print 2, same thing, but when I is equal to 3, if I is equal to 3 here is true, then I will encounter the continue keyword, and in this case, I will jump to the beginning of my looping, and I will go to the next value of I, so I will be equal to 4 without encountering the print I when I was equal to 3. So in this case, this loop will be printing 1, 2, then skipping the 3 because we have the continue keyword, and then going back to the looping with 4, 5, 6, 7, 8, and 9. It works differently than the break keyword, as you can see. So continue will only break the current iteration, not the whole loop. So next we will define functions. What are functions exactly? These are groups of instructions that you can execute by calling the name that you previously defined. So let's look at this example. I will start by the def keyword here, and then I will provide a name for my function. This is why I called it my function. And my function can take parameters, or it can simply take none. In fact, you can keep those parentheses here empty. Then we have the 2 points syntax, and with a single indentation at this level, you can put a block of instructions. You don't have to have only one instruction, you can have as many as you like, but at this case I only put only one, return a plus b. So this function basically will return the sum of the two parameters, the two provided parameters. Then in my program, if I want to use this function, I can simply call it by its name. My function 2 and 4 will be returning 2 plus 4, which is 6, and then I put all of this into the print function, so I'm going to printing 6 at this case. Okay, there's something here, just be careful, you cannot define two functions with the same name. In Python, if you do, the old definition is overwritten by the new one. This was not the case in C or C++. You could have done something called the overloading, but in Python we can't do this. Just avoid this, and it will avoid you lots of trouble. Now, functions can also have default values for parameters. For example, here I will provide 2 parameters when defining my function, a equal to 1 and b equal to 3, and I'll return a plus b. In this case, I have three different ways of using my function. Either I don't provide anything between parentheses, and in this case a will take its default value, which is 1, b will be equal to 3, and I will get 4 in return in my first case here. Then in the second case, I'm only providing the value for a equal to 0, and in this case b will take its default value, which is equal to 3, and I will get a return a plus b, which is equal to 3 in this case. B equal 3 plus 0, it will give me 3, and then print my function b equal 4. I will simply change a new value for b, and a will be taking its default value. Now you get the idea. These are the default values, and most of the functions that are predefined in the modules of Python, they have some kind of default values to make it easier for the users to use these functions. Also, functions can return multiple values in Python, which wasn't really the case in different languages. So I will define my div with a and b here as parameters, and I will declare a new variable inside, d equal to a, floor division by b, and a modulus b. These are d and r, the divisor and the rest of my division. And then I would like to return, instead of a and b here, it should be d and r. So in this case, my function will return two values. And in order to be able to use these two values, when I'm using my function, let's say my div 5, 2, I will have to store these two values in two different variables. And this is why I provided here x, y is equal to the result of my div 5, 2. Notice that the return values in general are also optional. I mean, functions can take parameters or they can take none, but also you don't have to return any value. You might have a function that simply prints a message on your screen, so you don't have to put always a return value for a function. And if you are not familiar with these symbols here, this one is the floor division, and this one is the modulus of the division. Okay, now let's do an exercise. We will write a function that takes one integer parameter and prints the numbers between 0 and this integer in reversed order. Like my function, I will provide 5, for example, and the my function will print on the screen 5, 4, 3, 2, 1, and 0. So basically the idea here is that I will start by the highest number, which is my parameter, def my function with a parameter called a. Then inside of my function, I will use the while condition, and as long as my parameter a is higher or equal than 0, I will do the following. I will print the value of a with the option and equal to space, so it doesn't jump to the second line immediately after each printing. And then I will decrement a is equal a minus 1, meaning the new value of a is equal to the old value of a minus 1. So I will go from the highest value, which is my parameter, I will print it, and then I will go backward one unity, one value. And in this case, just to make sure that my function is working properly, I will go backward outside of the block, and then I'm going to try it for, let's say, the value of 5. My function 5 as parameter. I will run this, and this is what I'm getting. I have 5, 4, 3, 2, 1, and then 0. If I change the value here, let's say I put 10, I'm going to run this, and I will have 10 to 0, as you can see, in decreasing order. There's a different way of doing this. If I define a new function, let's say, or the same function with the same name, my function, if I want to use a for statement, I will be using for a in the range function. I will start by the value of my parameter. This is my starting point, which is a, first parameter of the range function. Then I will stop at -1 excluded, meaning the 0 included with a step that is negative, in this case, a -1 step. And then I'm going to print A, in this case, with an end character that is equal to space. Okay, let's try this one. And if I run it, I have the same result as the previous function, 54320. And if I try it for the value of 10, for example, I have from 10 to 0 in this case. Okay, so we've seen two different ways of solving this. If the first one is more appealing because you don't use something built in Python, and if you are familiar with the range function, you can use the for statement in this case. Now let's continue with a small example. I will define a new function for the default values with a equal to 1 by default and b equal to 3, and then I will go inside the function and say, let's say I want e equal to a plus b, and then I would like to return the value of the sum, which is return e. Okay, it should be single indentation here, and outside of the function I will try and print e, and it's not going to work, and this will lead us to what is called the global and the local variables in this case. So what are local and global variables? As you can see, we have defined the C variable for the first time in our program inside of the block of the function. So it's inside of the function. This is called a local variable, and it's not visible outside of the function because for the first time C was declared within the function, so it will remain inside of the function. So the part of the program where C is visible is indicated by this yellow bracket here. Outside of this, there is no variable called C. So if I'm printing C outside of the function, it will return me an error message. This is what we just saw in our example. Now, if I define C outside of the function and I define another C inside of the function, these are two different variables. These are not the same variable. C equal to 0 is a global variable because it wasn't confined within a function or a block of instructions. It's simply at the highest level of indentation inside of my in my program. And then I have another C which is different, that is local inside of the function. So if I'm printing C here, I'll be talking about C equal to 0 and not the C that was modified by the function. Now, there is a way of modifying a global variable from within a block, from within a function. It's by using the keyword global, but the C variable here should have been defined previously, as a global variable. And therefore, the global keyword will give you access to that global variable from within the function. So you could modify it, read it, and so on. Okay, so we've seen this example where we tried to declare E inside of a function and then print E from outside of the function. And look at the error here. We have name E is not defined. So the program is not recognizing something called E. Now, if I'm putting global keyword here and E equal A plus B, and it happens that E is a global variable, in this case, E equal to 5 in here, and I run this, I will be able to modify the value of a global variable from inside of this function. In this case, it will be equal to 3 plus 1, and as we can see, the 5 was changed to 4. If I don't put this one here, global E, if I simply stick with E equal A plus B, and I run my program, E will always be, the global E variable will always be equal to 5. So I don't have access to this global variable from inside of my function, even though I've used the same name. Python will be declaring a new variable probably, which is E, which is local. And just to do this operation, E equal A plus B, and then to return a value E, and then the local E will be erased from the memory when we are out of the function. Look at it this way. Let's print the return value of my function. And let's provide different values, let's say 4 and 5. And then when I'm printing those, I have two different values. One is provided by my function, and the other one is the global value of E. So yeah, we have to use the global keyword to get access to the global E in this case. It cannot be used on the same line. We have to put it this way, E equal A plus B. And in this case, both values will be changed into 9 by the function. In Python, we have something called Lambda functions also. So to define a Lambda function, you start by the keyword Lambda, and then you provide the parameters of your function, 2 points, and the return single instruction. As you've noticed, usually Lambda functions are very small instructions. These are a quick way to define a small function. And you have to store this in a way, in a variable, in order to be able to use it later on. So for example, here I'm putting my f is equal to lambda, the keyword, x, 2 points, x times x. So basically this is a function that takes one parameter, which is x, and it will return squared of its value. These are very commonly used in Python, and they are very practical, as these are usually a single line quick definition of a small function with a small single instruction. Another example here, if you have x is equal to lambda a, b, and c, 2 points, a times b times c. This is a function that takes 3 parameters, and it provides you in return the product of these 3 values. Let's go ahead and try this as an example. Let's try, for example, my f is equal to lambda, the keyword lambda. And as you can see, it's in green now because it's a keyword. It takes a, b, and c, 2 points, and it will provide me the product of these 3 values, a times b times c. And then after this, in order to use this function, I will be calling the name myf, and I will provide 3 parameters. Let's say 3 times 2 times 1. And there we go, we have 6. Now I have a lambda function in my program. Okay, so Python is used a lot in data treatment and data science and so on. So it has 4 types of containers. You can put data and information or objects or values in 4 types of containers, and these are the lists, tuples, sets, and dictionaries. We're gonna go and see each one of those on its own, and we will be starting by the lists. These are, let's say, arrays that are resizable and can contain elements of different types. And they are ordered, which means that they have a defined order. All the elements have a defined order that will not change during the execution of the program unless we do so. At the same time, we can add, remove items after the list is created. So it means that the list is dynamic, it's not constant, it's not fixed. Imagine this is our list. It can contain different types of information. Here we have an object which is a string of characters. Here we have integers, for example, 21, 3, and 5. The indexing of elements is 0 based, so the first index or the index of the first element is 0, and then you have 1 and so on until reaching the end of the list. Let's go and see examples with more details on these containers. Okay, so how do you define or declare a new list? Let's say my list1 is equal to brackets empty. This is the first way Python will guess that this is a list, by using brackets. You cannot use different characters, you have to use brackets, as these are assigned directly to lists in this case. There's a different way also. If you are using the function named list, I can declare a list that is empty here by calling the function list parentheses. And you can declare a list by also filling or starting to fill some of the objects or the items that it contains. Here we have put 1, 3, 5, 3 integers, and 1 character, the A. And then, of course, in the program, you can add elements or erase elements from this list. Then if I want to print the content of a list, I can put print mylist3 and it will immediately print all the elements of the list. If you are coming from a different language, coding languages, this is very powerful in Python here, because you would know that this wasn't possible in the other languages. We had to go through a for loop and print elements each on its own. For example, if you wanted to print elements of an array in C++, you have to go through a for loop for I equal to 0 until I is reaching the end of the array, and then I will be printing the array element I, the first element, then the second, and so on. So here it just takes to call the function print, and then we provide the name of the array, the list, and everything will be printed automatically. So the elements of lists are ordered, and as we have said previously, we can access these elements one at a time. So I will try here mylist3 and access the first element, which index is 0, and I'm going to print this here. As you can see, we have 1, because 1 is my first element. If I want to access the second element, I can change the index to 1, and I will access the element number 3 here. I could change these also. I can say, for example, mylist element of index 2, which is the 5 here, is equal to 10, for example, and then I will print the whole list again, mylist3. Okay, and as you can see here, we've changed the index 2 element to 10, so 5 is replaced by 10 here, and then we are printing the whole list, and we have changed the 5 to 10. Okay, so you get the idea. We have access to any element of the list. We can also add elements, new elements to the list by using the append function. So I will put mylist3.append11, and I will print the new elements of my list, and I can see that 11 was added at the end of my list. If I want to erase the last element of my list, I can use the pop function. On mylist3, I'm going to use it in a new cell. Like this, we can pop, and then I will be printing mylist3, and we can see that the pop function did erase the last element of the list. We also have access to the length of a list. For example, I can use the len function, mylist3, and then the length of my list is 4, which means that this list contains 4 elements. As you can see, we have built-in functions from Python. They are very useful. I will not go through the whole list here because you have so many functions that we cannot spend so much time on, but you get the idea. And if you need to know what are these functions and to check if anything you need to use is available, you can go on the websites of Python or just Google list of built-in functions or list functions in Python, and you would get a wealth of information through the web. Also, one important thing is, if you noticed, our lists can contain different types of data. Here we have a string, here we have integers, you can have also floats, so it can be mixed types of objects within a list. Even lists can contain other lists, which means that you can put a list as an element inside another list. And this would look something like this. mylist4 is equal to elements, let's say integer. Then the second element, I would like it to be a Boolean, so it's true. Then you can put another list here, for example, and okay, it can be, let's say, a series of numbers 0, 2, and 3, let's say. So this is a list that contains another list. Let's print it and see how it looks like. And just as we've defined it, no error messages, no nothing, which means Python is understanding what I'm using here. Of course, indexing becomes more complex in this case, so if I want to access any particular element of this list, I can put mylist4. Let's see the index 0, 1, and 2. So I'm going to go to this list here. I'll use first the 2 index, and then inside of this element, I'll use a second index to, let's say, take out this number, which index is 1 inside of the small list. Let's print this. And then you get the number 2, which is indexed by these two numbers here. Interestingly, you can also add two lists together and put them in a third list or in different lists. For example, here, my list 1 is equal to my list 3 plus my list 4. And if I execute this, I would like to print my list 1 to see what is the content. It actually concatenates two lists, the two elements. So you can see that my list 3 is this one, 1, 3, 10, and A. And it was put here, 1, 3, 10, and A, and then just after it, we have the list 4 elements, and all of these are now contained in my list 1. So you can immediately add elements together into third list or fourth list and so on, which is very flexible, very powerful feature. And you have other functions that you can use here. I'm giving you just some examples. Append, it will add an element at the end of the list. Clear will be erasing the list, it will make it empty. Copy will provide you a copy of the list. Count will count the elements. Actually, a count, if you provide a value to the count function, it will count the number of occurrences inside of this element inside of the list. Then you have index. It returns the index of a certain element. It's for searching inside the lists and returning the index of the element. And then you have insert. You can insert an element at a position inside of the list. Pop, you also can erase elements. If you don't provide any index here for the pop function, it will simply erase the last element of the list. The remove actually removes the element not at a specific position or a specific index like the pop function, but it removes the element with the value that you provide here between parentheses. And actually it will remove only the first occurrence of this value. Then reverse will reverse the order of the list, and sort will be sorting the list. So these are just examples to show you that you have built-in functions that you can take advantage of. Instead of coding things on your own, you can simply use functions, and they are very easy to use and very powerful. Our next data containers are tuples. Tuples are very similar to lists, meaning they are ordered. They keep the same order of elements throughout the program. And the first element is indexed as 0, has an index 0, then 1, then 2, etc. However, they are unchangeable. They are constant. You cannot change elements of tuples during your program. You cannot add new elements to a tuple. You cannot erase any elements from a tuple. Tuples should remain the same throughout the whole program. So how do we define tuples? We can start by name of a variable. Let's say my tuple 1 is equal to round brackets or parentheses. This is how Python will know that this is a tuple. Now this one is empty, or we can use my tuple is equal to tuple. We call the tuple function the constructor of tuples. Here also I left it empty, and as usual I'm gonna put here 2, and I'm gonna define a third tuple. 3 is equal to, let's say, 1, 2, and 3 elements of integers. So I can execute this, and now I will be trying to modify this, the elements of this tuple. Let's access the first element, for example, my tuple 3, and look what's going to happen. Tuple object does not support item assignment. This is because tuples should remain constant throughout the whole program. Now, just to check what we've said previously, if I want to declare a new tuple with different types of elements, meaning 1, 5.5, a float, and then another tuple inside of, let's say, 10, 10, this will be no problem because tuples can contain different types of elements at the same time. Now we can access these elements, but we cannot modify the elements. If I would like to print my tuple for the element number 2, which means this tuple here, 0, 1, and 2, index 2. And the second index, I will use simply 1, for example. So this is not a problem because we can read from a tuple. However, we cannot change or modify any of its elements. I can also use some functions to check, for example, the length function to check the length of my tuple 4, and it will provide me that it contains 3 elements. And because tuples are constants, basically, so we are very limited with the operations we can apply to these containers. So Python has only 2 built-in functions that you can apply on tuples. The first one is count, which will return the number of times a value occurs in a tuple. And the second one is the index, which will search the tuple for a specific value, and then it will return the index of the position where this element is found. The next type of data containers are sets. So these are basically arrays that are not ordered, so we don't have any indexing here, and the elements will not keep the same order or a specific order during the program. We might fill elements in a set, however, we have no idea how these guys are filled. We can change set elements. I mean, we can add elements and erase elements from sets. However, we cannot allow any duplicates. So you cannot have the same element twice in a set. Basically, sets can be used to shrink duplicates from lists. This is one sort of applications. And my sets can be defined using braces here. For example, we are defining my set 1. It contains 3 different strings, 3 different words. This one contains only Boolean variables, and we can have mixed types of elements. My set 3 is equal to braces. I could put 1, 2.5, a float, and after I can put again me. So this wouldn't be any problem for Python if I execute this, no error messages, so this is allowed. And we can also use the set function to define sets instead of the braces. For example, here I replicated the my set 3 elements inside of my set 4. Notice the double round brackets here, the double parentheses. And just like other data containers in Python, these gives you access to a set of functions that are built in Python where you can use those. So for example, you can apply the add function in order to add elements to the set. You can clear in order to remove elements from the set. The pop function will be removing, since we don't have no order and we don't know which is the last element, it will be a random element removed from your set. The union can provide you a set containing the union of 2 sets. So you have to have 2 sets at least to use this function. You have so many functions, we will not detail all of these for now, but you get the idea. This is our 3rd data container. We still have 1, which are the dictionaries. Dictionaries are slightly different from the other data containers in Python because here we have to provide data values with the keys, meaning each data value has to be provided a key which will act instead of its index. So how do we define a dictionary? Let's take this example here, and which is equal to, between braces, I have the first element which has the key and the value assigned to this key separated by 2 points, and each element is separated by the other element from the other element by a comma. Here we have a comma 2. So I have here 3 students, for example, student A, which has a level of good, and student B has a level of average, and student C has a very good level. We don't have to stick with any types of data here. I've just used strings for keys and values. It doesn't matter. You can have here their averages. You have, for example, you can put an integer or a float, or here you can provide a name or simply an integer or even a boolean. You don't have any specific mandatory type for the key, type of data for the key, or type of data for the values. Now, but when you have elements providing key and value separated by 2 points, and the elements are separated by a comma, and all of it is contained within braces, so these are dictionaries. So if I want to access an element of my dictionary, I can simply print my dictionary, and I will provide the key between those brackets, let's say student C, for example, and I will be getting the value assigned to the key, which is student C, which is very good here as a result. Dictionaries are changeable, meaning that we can modify the content of a dictionary during our program when we are coding. We can add or remove items after the dictionary has been created. However, you cannot duplicate keys, meaning student A, for example, here can only have one key, and we can only have one element with the same key. So you don't have the right to have duplicates, since if you try to do so, you will be erasing the old values assigned to the same key. And just like the other containers, these dictionaries, they give you access to built-in functions. We've seen examples before. So we have the clear function that will erase the content of a dictionary. The pop will be removing the element with the specified key, because you have to provide the key here. Keys will provide you a list of the dictionary's keys, and so on. So some of these functions are specifically used only for dictionaries, as you can see. So you only have a key in the case of a dictionary, and some others we've seen exactly the same overloaded functions for the different type of data containers. Remember, this is just an introduction to containers, so we cannot detail all the functions here. We just want to stick this with the minimum amount of time to get you started. So I'll not go through the details. However, you can find really good resources online if you are interested in using these types of containers. I'm gonna stop here for this video. I hope you guys found the information helpful to get you started with Python. Thank you for staying that long, and good luck to you in your coding adventure. If you appreciated the content, please don't forget to give a like and maybe subscribe. It would be of great support for more videos like this one.